So, any general questions in here on PA3? People are doing well on it. There's details for that final like 5% of getting things perfect, but let's see. Are we supposed to just keep the game going in a loop like the sample and temp, or are we supposed to end the program after each game is over? I would rather you keep continuing to play the game. That's going to make it easier to grade because I'll need to play the game several times. Let me see what the assignment says. Da, 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 20 questions. Yeah, I didn't specify, but yeah, it's fine to just make it a while forever loop and just keep playing until the end. Yeah, you get to play 20 questions all weekend. Isn't that awesome? Yeah, I'm okay with Control C to leave the game. Or you can ask if the person wants to play again. That's fine too. Yeah, sometimes I get to play the stick game all weekend, which is like extra bonus good. So that's what a PhD will get you. And occasionally I grade and things like that, but totally, yeah, it actually is living the dream. No joke there. All right, I still got a camera. Let's see. Other PA3 questions? Yeah, thanks. All right. Well, let's take another look at you can hide the stick game in PA4 as a secret bonus Easter egg. Yeah, I think I am going to offer that. If you make a graphical version of stick, that would be pretty cool. Up, up, down, down. Yeah. All right. So let's I'm waiting for that to end up on Steam. Let's make a JFrame from just plain old Java, just written on the command line, without Eclipse and Window Builder and all of that stuff. Let's see what we have to do, and it's actually pretty pretty straightforward. So I think I called it gmain, class gmain. So here's our main program, and I'm going to make gmain extend to JFrame. Now it doesn't have to be my main program that's extending the JFrame. I could make a different class that extends a JFrame, and I could construct one of those. But I'm gonna do this. I've never had anyone do the stick game as an SLP. It could be the stick game learning project. All right, so let's construct gmain. And let's construct a copy of ourselves, SGSLP. Yeah, that could be your capstone at WSU. You could do a cool stick game though. I mean, you could hook it up with a robotic arm and have it, actually pick up sticks and play a user. Um, and then like when it wins, it can like turn on a flamethrower or something. There's lots of possibilities. So let's construct a copy of ourselves, right? So we're making a G main, and let's set the visible. All right, so let's try that, and we're going to need to import a J-frame. And I don't think we got enough to make this work yet, but let's see what happens. Let's see, no suitable method found for set visible. So set visible takes an argument. All right, that worked. So we can run this, and I'm going to have to come over here and retrieve this. So I have the world's smallest window over here that was created. And if I grab a corner, I can make it bigger. There's my J-frame, right? So it's like, 2 lines of code to make this happen. And there's our object. And we can move it around and resize it and so on and so forth. And if I hit the X, the window goes away, but my program continues to run. It's still like, hey, I'm just kind of hanging out. So it's not, a very functional window, but that's really all you need to create a J-frame, right? Yeah, you could have made a smaller pixel. Technically, you could make it 0 by 0, I think. Or a third, nice. All right. Now, if we want to make this useful, we can do some other things. So let's try this. Let's give it some size. All right. So now I've got, a 600 by 400 window. And I think if I make this 4,000, all right, now it pops up on my second monitor. So that's pretty good. It still doesn't, exit when I close the window. It's still running. But this is just other things that need to be set up. So, infinity by infinity, that would be a pretty big window. So set default close operation. Alright, so there's our window, and now if I exit, it will terminate my program. So what is this? What is jframe.exit on close? What kind of thing is that? So if think back to statics, right? If we had an object, we could say object dot something. That's instance method. It's a method that's being accessed from an instance of an object, of a class, right? From an object. When we use the name of a class, this is a static. So in this case, this is a static field. And if you look at the JFrame documentation, under fields, there's a field called exit on close. It's just an integer. What's its value? I don't know. Maybe it's 42. Maybe it's 1939. It's some integer, but it's a particular magic number that's been set aside to say, hey, if you call set default close operation with that number, it means I want to exit when the window closes. And what does that equal to? Well, I could print it out to see what the value is, but it's just a flag. But instead of having to say, when you want to close, when you want exit on close, call this with a 17, right? We set up a symbol for it. So that's a common use of statics, and it's exactly the same as color.red, right? So it's just a way to store a magic value. So set default close operation is a method that's part of a JFrame. And that's down here. And so it takes an integer argument, which is the operation, and tells it what to do, and you've got these options. All right, so some conversation going on in chat about can we run this on the Linux server. So the Linux server is headless. It doesn't have a display. And even if it did have a display, right, that's not the display that we have access to. So if I SSH into the Linux server, well, let me do this. May as well make it public. So I can compile this, that'll work fine. When I try to run it, it's going to complain there's no X11 display. Right, but the program performed an operation which requires it. You got to appreciate this sort of level of proper sentence construction. That's a pretty nice error message that pretty clearly tells you. The other side of this is an abend. So on the old IBM 360s, you'd run a program and it would say abend, and it would print out 8 hex characters, and you had to go to a book that was about 3 inches thick and look up that code to see what the error was. So this is pretty clear, right? There's no display variable set, and so we can't create this window that we're trying to. And so it's a headless exception, which sounds cool. But we can make this work if we want. So I don't recommend doing this because it's really slow, and I think if too many people do this, we're going to notice it. But if I do an SSH-uppercase X to Linux, and I try to run this, this may or may not work. Yeah. And actually, let me change my location here. Yeah, this is good time stuff. We'll see if that works. So X Windows, right? It mentioned X11. X Windows is a really old windowing system. It was developed, I think in the 80s, possibly a little earlier, and it's still in use today. And Xcode that I wrote back in the 80s still runs today on a modern system. But the idea of X11 was that you could run code on your machine that's supposed to do graphical display, interaction with mice, things like that. But if you wanted to run this code on a remote machine, you could set up a connection between what's going on in that remote machine and your physical hardware. So you could create a window that would display on your terminal, and you could use your terminal's mouse, and the mouse events would get sent to this remote application, and so on. And it still works today, but you have to set it up because you don't want me to be able to run a program that suddenly takes over your display or starts picking up your mouse movement, right? So you have to set up an authorization between your physical hardware system and the code that's running on this remote server. So this is either working, and I can't see my window, but let's just try a program that we know works. Let's try Xeyes. Oh, no, that does work. Because I got my Xeyes working. So this is a graphical application running on the Linux server that's interacting with my my local setup. So I don't know where my window is appearing, unfortunately, but I think this is actually working. I haven't tried this in a while. But anyway, so an SSH dash uppercase X will get you most of the way there. If you go in PuTTY, it is what happened to my window Wednesday. If you go into PuTTY, under the configuration options, there's an option for SSH tunneling, and you can mess around with that and get it to work. But if you do get it to work, it is really slow, right? Because you're sending back, every lots of commands to do every display and respond to every event and so on and so forth. So it definitely runs slowly. And I've seen some people, get PA4 to work on the Linux machine, but it's a performance hog. And it's very strange that I can't kill it. All right, so this is kind of a minimum. It's only due at 3 a.m. Yeah. This is kind of a minimum hello world for making a GUI, right? It actually does a little more than the minimum. Because we've got a window and we can close it out and so on and so forth. So how does this relate to things like buttons? So let's import a J button. And let's make a J button. So we'll make a new J button, we'll put a default label on it, and that'll come file fine, but we're not going to see the button because we haven't done anything with it. We constructed it, but we haven't used it. So where would we like to put that button? Well, let's just throw it in the middle of our screen. Um, so let's set some bounds. So I don't know, 4200, comma 300, and let's make it 100 by 70. So that specifies a location for the button, but it's still not going to be visible. It's still not part of the visual thing that we're displaying. So we could try to add it. Right, and so there's a button, and it's a big button, right? It's filling my entire window. And if I make my window bigger or smaller, my button continues to get really big, right? Now this is not a very controlled way to make a GUI, but you know, I can make a button, I can give it dimensions, and I can add it to my JFrame, right? And there's a button. But the usual way that we set these things up is, you know, we make a JFrame, which is a large window that also has, you know, these little buttons up in the top, and this button up here, and maybe a title, and so on and so forth. And then we'll usually construct a panel. Inside here, and then on top of that panel we can place our individual widgets, our buttons and our radio buttons and checkboxes and so on and so forth. Good idea. So clicking the button doesn't do anything, right? Because we talked yesterday about this idea of, you know, action listeners and making something that will respond to events. But nonetheless, this is all you need to really get a piece of button displaying. Oh, the space demodulator. All right. So how do we make this thing respond to let's respond to mouse clicks. So we're going to add an action listener. And add action listener needs a mouse listener object. Okay, so I'm just going to add something called my mouse listener. And my mouse listener is going to be an object of type my listener. All right, so we're going to define a class called myListener, which is going to be the kind of thing that we need to pass to an action listener. And myListener is I'm going to make a myMouseListener, which is an object of type myListener. I'm going to construct it here and then pass that to the addActionListener method. All right. So let's hold our thought on that. And let's make a myListener Java. All right. I'll be good and make this public. All right, and myListener, I'm going to say it implements an action listener. And so here's a new keyword. Implements, not implements. So we know about extending classes. I could say myListener extends action listener, and I would basically inherit all the stuff that's inside action listener, and then I can go ahead and modify or add new things to it. Implements is a little different. So implements is a keyword we use when we want to basically extend an abstract class. So what's an abstract class? An abstract class is a description of a class without any code in it. So here's the deal. To create... Oops. To create a listener that can go in as an argument to this add action listener method, we need to write a class that implements certain methods, that has certain methods, in particular a method called action performed that takes an object of type action event. Okay, this is the stuff that, you know, Window Builder creates for us in Eclipse. We need to create an extension of this thing that actually includes the code for certain methods. And so implement says, you know, I have a description of the required methods in here, and some of those may not have any code, but I'm going to add some code for some of those here. All right, so we're going to create this myListener that implements an action listener, and I'm going to write one method in here, which is going to be public void action performed. And I'm just going to say it's taking an argument of type action event. And I'll just say we got a click, and I'll print out this argument arg. And that's my whole class. It's one method. All right, but myListener.java, right, has the code for this method, which is part of this myListener, which we're using this keyword implements. This is an action listener now, and this is the version of the action performed method in this class. And so if I construct a myListener up here, my mouse listener should be an object that's suitable to pass to the add action listener method. Okay, long story short, let's just compile all of that. And lots of errors because I need to import. I need to tell it what an action listener is. So action listeners come from Java Abstract Windowing Toolkit .event .action listener. And I'm also going to need to know what an action event is, so I'll import that. This is incredibly clunky. But there's our button, and when we click it, it executes our code. And take a look at this argument, which is passed to our action performed method. So there's our print line message, right? Got to click. The argument is an action event. Action performed was the thing that caused this to fire. Command equals, well, that's the label on the button that was pressed. So if you have multiple buttons, you don't necessarily need different handlers for each button. You could use the same handler, and it would simply tell you what the label is on the button. So if your labels are unique, you can use that. When? Well, this looks like a timestamp. 73,263, 52,057, so I'm guessing this is number of seconds or milliseconds since January 1st, 1970. So this is a timestamp telling you when the event occurred. This is a J button. This is telling you something about the position of the button. And, you know, other information on the button and so on and so forth. All right, so we can interact with events without having to use Eclipse, right? And certainly anything that we write, whether we write it in Eclipse Window Builder or we write it from the command line or something else, we can run it from the command line. We don't need the infrastructure of an IDE to be able to create windows and run our code. All right, so one more quick run through this. What's going on here, right? Create a frame, create a button, add the button to the frame, and then the mouse business is down here. So add action listener says what should we do when the button is clicked, basically. And in order to know what to do, we pass an object of type action listener to this method, right? Now the particular object that I passed was my mouse listener, which is actually a my listener, but my listener is basically an extension of an action listener. But when we say implements, it says this is not, you know, a class that we can extend because it doesn't have any code in it, right? It's really a wrapper for a class we want to build. And it has templates for all the different types of methods that we might want to implement, including action performed. So if we want to do this by hand, right, we need to, you know, have some good documentation on Swing and really dig into, you know, the different prototypes for different kinds of classes we want to build, depending on the widgets involved and so on and so forth. This is part of why we're using Window Builder, right? So we don't have to get into this level of detail. But at the bottom level, it's just more Java, right? It's, you know, this is a class that I'm defining. Here's a method I'm making in the class. And I'm creating an object of that type. And I'm passing it as an argument to this method, which is a method in this object button, which is an object of type J button, which comes from javax.swing. January 1st, 1970 is considered by a lot of systems, including Linux, to be sort of the epoch, so the beginning of time, and things are counted forward from that in seconds or milliseconds and so on and so forth. So with a 64-bit unsigned long, you can get pretty far into the future starting from that point, but it lets you standardize time as a single number. Yep, it's all Java, always has been. All right, so that's a that's a look at that. Well, I don't know if time started before today, actually. That's the weird thing about time, right? I could have just been born an hour ago, but born with, like, you know, all these memories. All right, let's play with javadoc. And I am going to do this from Eclipse, just because it's a little easier. But this works, you know, perfectly fine from the command line also. So let's close this project. All right, so let's do our triangle class. You were only in 2000 for half the year. That's a cool way to think about it. All right, so let's resurrect our triangle class. We'll make a new class, and we'll call it triangle. All right, there's our triangle class. Back from the beyond. '90s were definitely awesome, I agree. All right, so remember this class, right? We had a class named triangle. It had some arguments. We have a default constructor. We have a an add method, a reset method, and a toString method. And I'm going to go ahead and make my class public. All right, so let's, I can tell you about Y2K sometime because I was in on the hype. All right, so Java documentation, right? So there's these documentation pages we get. You know, if you want to know what the string class looks like, there's this nice page that, you know, tells you about the class, has a preamble, shows you the different ways to construct it and the methods and so on and so forth. We can create the same documentation ourselves. You can do this from the command line, you know, using VI, for example. It's a little easier with an IDE that has the hooks for this. So let's go ahead and let's start writing some comments in here. So, you know, I've already said basic class for defining and working with triangles. What I'm going to do is I'm going to start a command line, and instead of saying /star, I'm going to say / and 2 stars, and hit an enter. And you notice it created a bunch of text here, right? It gave me a block of comments, and it also included this thing that said author Nick. Okay, so this is kind of like a markup language. I can put tags in here in the form of comments that will get turned into really pretty Java documentation. Okay, so what am I going to say in here? I'm going to describe my triangle class. All right, so all right, so I've added a comment block here in the beginning, in front of my class definition down here, and down here where it says defining a constructor, I'm going to do the same thing, /**. And I've got a block of comments here. I'm going to say default constructor makes a 1x1 triangle. And down here by where I have addition, I'm going to say /**. And when I hit enter, it fills in some more tags for me, right? So I'm going to put a description of this here. Allow the addition of triangles by adding their dimensions. Okay, and it's telling me there's a parameter called add me. So I'm going to describe what they add me parameters for. So add me is the triangle to be added. And the return value from this is the newly constructed triangle, which is the sum. That's not a very good comment, but you know, that's okay. And I think I got one more method in here that I'll describe. So I'll say /** and hit enter. And you know, there's no arguments, there's no return value here, but I'm going to describe this anyway. Reset the triangle to a standard 10 by 10. All right, so I've added some comments in here, okay? What this lets me do, and I can do this from here, I can say project generate javadoc. And there's a bunch of options in here. I'm just going to say finish. And I'm just going to say yes to all because I don't want to read. And I've got a new tab under here called doc. And if I expand that, I see I've got a whole bunch of files and subdirectories. And there's one file in particular called index. So if I click on that, it will open up a browser inside here. And guess what? There's my documentation for my triangle class. So class triangle, it's extended from Java language object. Public class triangle, basic class for creating, examining, and working with triangles. Author Nick and CSE223. Here's the constructor, so there's the only way to construct it. Here's the add method and the reset method and so on. It's all hyperlinked. I can click on add, and there's a description of the add method, right? Allows addition, what does it return, and so on and so forth. And you get this almost for free, right? If you're putting in documentation anyway, you know, this is pretty much a freebie. And it just makes an HTML file, so what is this called? Triangles. So I've got a new folder called doc. And if I look in there, you know, there's a gazillion files set up. But index.html is, you know, always the root of these things, and it's just a bunch of documentation. So I can, you know, run that through Firefox, and bingo, there's my pretty documentation. So there's all kinds of things you can do with javadoc, but you know, it's basically a markup. So you can say author to say who made this. You can say parameter to list the inputs to methods. Return to show the return value. You can mark something as deprecated. You can make links to other information and so on and so forth. So that's something to play with. All right, let me see what's going on in chat here. Mostly end of the world stuff, so nothing to worry about. Year 2000 was interesting. Ask me about it sometime, and I can tell you some stories. And I did a lot of the Y2K mitigation work for the place I was working. And we actually did find a few issues that would have been problems. They wouldn't have ended the world, but they would have been problems if we hadn't fixed them. But yeah, it was a good deal of hype. So, good stuff. All right, so we'll do an open lab tomorrow for final issues with PA3 and so on. And then Friday we will jump into PA4. That's all we got for today. Have a great afternoon. I will see you next time.